Hello viewers, in our today's lesson we shall be talking about Pythagoras theorem, and we intend to cover the following by the end of this lesson: squaring a number and square roots, calculating the hypotenuse, solving real life problems, and finding the length of the smaller side of a triangle, distance between 2 points, and finally mixed problems. So our aim for this lesson under squaring a number is to understand the term to square a number, and later on we need to understand what is meant by the term squaring a number. We also will be able to calculate squares both mentally and using the calculator. So that is what we need to do in this. So starting very first, to square a number means multiply it by itself, multiply that number by itself. That is what is meant by squaring a number. Then we look at an example here. We have 9 square, and this means that it is 9 times 9, and you'll get 81. The other one is 10 square, and this means that it is 10 times 10, and you get 100. So in other words, the square of 9 is 81, and also 10 square is 100. So to square a number is multiply that number by itself. Now that we know how to square a number, then we can undo this by asking which number times itself gives 81. Which number times itself gives 81. So we now want to introduce the concept of square root of a number. Square root of a number. So of course the answer is 9, and this is expressed as the square root of 81 is 9. Something that is written in symbols as the square root of 81 is equal to 9. So that introduces the concept of square root of a number. Now let's now move to right angle triangles. Right angle triangles. Now that we have understood squaring a number and square root of a number, because we want to use them to introduce the whole concept of Pythagoras theorem. And now the aim of this lesson is to investigate the right angle triangle and to come up with a relationship between the length of its two shorter sides and the longest side, which is called the hypotenuse. So in the diagram beside this, we have a triangle, a right angle triangle with sides A, B, C. And now, what is the length of A? This is just a simple question that you can ask ourselves. And probably you can see it is drawn in the grid there, graph. And the length of A will be in units. So as you can just count, A is 3 units. A is 3 units. So we have 1, 2, 3. So the length of A is 3 units. And what is the length of B? The length of B probably is the height of this right angle triangle, because it is 90 degrees at a point. One of its angles is 90 degrees. Then the length of B is 4 units. And what about the length of C? Probably you can get that. You will measure and get 5 units. You will get 5 units. You can just have to draw this diagram in your graph book and then be able to understand what we are doing here. Now, let's have a different triangle, a right angle triangle with the base, with the height and hypotenuse. Now, what is the length of A? In this case, you just have to count and you will find that it is 6 units. It is 6 units. And again, the height, what is the length of B, which is the height? You will find out that it is 8 units. That means with this, you can calculate for C. That is the hypotenuse. And then if you copy the triangle into your jotter and measure the length of C, you'll probably get it to be 10. Okay. Another extract of a triangle in this will be a right angle triangle ABC, the sides. Then you again ask about the length of A, it is 5, length of B 12, and probably the length of C will be 13. With the base and the height, you can just count the unit, the number of squares that are there, and you'll get your answer in units. Okay, copy the table below and fill in the values that are missing. So we have A, B, and C. The first column for A, we have 3, 5, 6. B gives us 4, 12, 8. C gives us 5, 13, 10. And now we want to take a set. A set means A, B, C. And now we square that set. So the first square will have the following figures. Yeah, so we have A square to be 9, B square 16, C square 25. That is for the first set. For the next set, we have 25, 144, 169. And the last set is 36, 64, and 100. So there's a correlation in these figures because they basically form, especially the first set, ABC, they are the ones which form the Pythagoras theorem, the set that will give us the Pythagoras theorem, the sides. Now, you can spot any relationship between A square, B square, and C square, because when you take 9 plus 16, definitely you get 25. So that means A square plus B square is equal to C square. And there's also a relationship in the second the second set, that is 25 plus 144, you get 169. And that's why we say there's a clear relationship between these figures. 36, 64, and 100. When you take 36 plus 64, you'll get 100. And we conclude that A square plus B square is equal to C square. Now, let's now come up with our Pythagoras theorem with from a triangle of sides A, B, C. And now from this triangle we have it that when you take A squared plus B square, you'll get C square. And the equation is only valid for right-angled triangles. It is only applicable to triangles that are right angle. And so we want now to look at how to calculate on some of the sides of this right angle triangle, and probably the hypotenuse of the right angle triangle. And now we have our aim being using the Pythagoras theorem that we have just come up with: A squared plus B squared is equal to C squared. And you shall be able to calculate the length of the hypotenuse, which happens to be the longest side. And then we are also going to know the term hypothesis. What really is the meaning of this term, hypothesis? Hypotenuse. Hypotenuse, which is the longest side. Now, we also are going to use Pythagoras theorem to calculate the hypotenuse. In our first question to this, calculate the longest length of the right angle triangle below. And now you realize that the longest side is labeled C, the base is 12 of the triangle, and the height is 8. Definitely this is a right angled triangle, and to get the missing or the unknown side C, we apply the Pythagoras theorem that says a squared plus b squared is equal to c squared. So we shall do substitution so that we get the value of c. So 12 squared plus 8 squared, you will get now 208 equal to c squared. So to remain with c alone, we square root both sides, and the answer will be 14.42 kilometer if the units were in the values were in kilometers. Number 2, an aeroplane is preparing to land at Glasgow Airport. It is over Lennoxtown at present, which is 15 kilometers from the airport. It is at a height of 8 kilometers. How far away is the plane from the airport? So that is our question that we need to solve using the Pythagoras theorem. Now, the diagrammatic representation of this, of the aeroplane as it prepares to land in relation to the airport and the town, has been given below, and we find out that it is a right angle triangle. Now our question is, how far away is the plane from the airport? We have it that the base of this triangle is 15 kilometers, its height is 8 kilometers, and now we want to determine its hypotenuse, and that is where we use the Pythagoras theorem, which states that a squared plus b squared equal to c squared. Now we substitute. We have 15 square plus 8 square. It will give you 289 to be c squared. So to find c, then we square root both sides, and that will give us 17 kilometers. That is the distance away from the airport. Now we want to solve the real life problems using the Pythagoras theorem, and we are going to show how Pythagoras theorem being used to solve real life problems. And to be able to solve the real life problems using the Pythagoras theorem. Now, when coming across a problem involving finding a missing side in a right angled triangle, you should consider using Pythagoras theorem to calculate its length. And now we have the first example here. A steel rod is used to support a tree which is in danger of falling down. What is the length of the rod? And that's the question has been shown. We have used a diagram to represent the concept being asked in the question. And now we have that the height of the tree is 15 meters. The base of from the foot of the tree to a certain length, it is 8 meters. And then we are supposed to find the length of the rod which was used to support this tree from falling. Then here we use Pythagoras theorem to be able to find the length of this rod. Now, having that a squared plus b squared is equal to c squared, then with the dimensions given in the diagram, then we substitute to find the length, whereby c squared is equal to 289, and to find c we square root both sides, and the answer is 17 meters. That is the length of the rod. Example number 2, which also has got a real life problem. A garden is rectangular in shape. A fence is to be put along the diagonal as shown below. Then what is the length of the fence? So we have the diagram is in a rectangular shape with the length 15 meters, width is 10 meters. The diagonal, which happens to be a common hypotenuse, it is a common diagonal for both the two triangles formed, and it is our hypotenuse. So we are supposed to find that hypotenuse, and that is where we apply the Pythagoras theorem, substituting, because now we have the sides. So we shall get 10 square plus 15 square, we have 325 to be the value of c squared. So to find c, we square root both sides, and we have 18.03 meters. Let's now move to length of the smaller side, and probably this is what we intend to do. We are going to show how Pythagoras theorem can be used to find the length of the smaller side, and also going into the example, we have that to find the length of the smaller side of a right-angled triangle, we simply rearrange Pythagoras theorem, and we shall be able to see which side is missing. And now, in an example, find the length of side A in a triangle of sides A centimeters the base, height 12 centimeter, and 20 centimeter, which is the hypotenuse. But remember, we have that c squared is equal to a squared plus b squared. Now we have c squared, we have a b squared, that is the height, and now we don't have the base. So we will make a squared to be the subject of this formula, and now it is a squared equal to c squared minus b squared, by taking b squared to the other side, the left hand side, where c squared is. So we do the substitution, and we shall have a squared is equal to 20 square minus 12 square, and a squared will give us 256 from your calculator. And to find a, you square root both sides, and the answer in this case will be 16 centimeters. That is the length of the base. So you are supposed to check the answer always smaller than hypotenuse, because we believe that hypotenuse is longer than the two sides. That is why the two sides are referred to as the shortest sides of right angle triangle. Length of the smaller side, we want now to use have a different view on the other side, that is the height, to see if the formula can still be used to get the length, that is the height of a right angled triangle. So we have the values we are going to substitute in the formula, but you realize that we have c squared is equal to a squared plus b squared. But now that we want b, which is the height of this hypotenuse, height of this right angle triangle, then we are going to make B the subject of the formula, making B squared to be alone on one side. After that, we substitute. So 10 squared minus 8 squared, you get 36. Now that is the value of B squared, and probably the value of B will be 6 centimeters, the height of this triangle. You also check if the length of that side is smaller than hypotenuse. Finding the length of a line, we intend to show how Pythagoras theorem can be used to find the length of a line. Applying Pythagoras theorem to find the length of a given line. Now, we have a grid here, and we've been given the coordinate of a certain point, 2, 4, and the coordinate of the other point, and it's 7, which is 7, 7. That is the coordinate. Now, with those points, we can now make a line, and you need to discuss with your friend how we might find the length of the line. To find the length of this line, we are going to extend both of the points to meet at 90 degrees at a certain point, and then you realize that they meet at that particular point of coordinate 7, 4, and you realize that the point above the point of intersection, that is 7, 7, is perpendicular to this point, the point of intersection. So you make a line, and probably you come up with a right angle triangle of unit, the base 5, and unit height 3 units. So with that, now we can find the hypotenuse of these 2 points. I mean the right angled triangle formed. Now, C squared equal to A squared plus B squared. We substitute, we have 5 squared plus 3 squared. We get the value of C to be a square root of 34. That in decimal is 5.83 to 2 decimal places. And so that is the height, the length of the hypotenuse or of that line. Now, Pythagoras theorem, to find the length of a line, we want to look at another example, and we have the first point 0, 6. That is the coordinate of the first point. The coordinate of our second point, so that we form a line, is 9, 1. 9, 1. We can join the 2 points. So after that, we can now form the point of intersection, because these 2 points can be dropped to meet at, using a line, to meet at a certain point. So the meeting point is 0, 1. So the length of the base is 9 units. The length of the height is 5 units. And therefore, with that information, we can now we really see that it is a right angle triangle. So the 2 points are forming the hypotenuse of a right angle triangle. And now we substitute into our formula 5 squared plus 9 squared. You get the value of C to be a square root of 106, and that is 10.3 units. So as we conclude, let's have a summary on the Pythagoras theorem. And as we know, the right angle triangle is used to derive the Pythagoras theorem, because it only applies for a right angled triangle. The base is A, height B, and the hypotenuse of this triangle is C. So you can be asked to find the hypotenuse, which is the length C, and probably you use the formula C squared equal to A squared plus B squared. If you are asked to find the shorter side A, then you make A squared to be the subject of the formula. So you use A squared is equal to C squared minus B squared. If you are asked to find the shorter side B, then you make B squared the subject of the formula. So you have B squared is equal to C squared minus A squared. So a Pythagoras theorem can be applied in the following figures. So we go through these figures. Probably you can be told to find the perimeter, can be told to find the length of a given side, or any other question that may really want you to apply Pythagoras theorem. So thank you for watching this lesson.